Hello, Sans HackFest. It's exciting to sort of be here with you. So my name is Carrie Roberts, and I am a blue teamer for Walmart. I started out as a web app developer, and I learned about security kind of the hard way by failing a pen test. And that's what got me interested in security. And I found Sans and was able to do their master's program and became a pen tester. And then I switched to red teaming, now blue teaming. I love to learn, and that's probably why I've switched around so much. I am one of the atomic red team maintainers and developers, which means when people contribute in the community, they contribute to this atomic red team project. I review those contributions and approve them. And I also do a lot of development myself for that project, which is what we get to talk about today. And I've come full circle and also teach cybersecurity classes as well. So that's exciting for me to go from not knowing anything to learning a bunch and now being able to share that knowledge with other people. So the Atomic Red Team project is a project started back in 2017 by the folks at Red Canary. And they open source this project so that the whole community can contribute. There's actually 200, as of this afternoon, 278 contributors that have given of their time and their code to emulate attacks or to write emulated attacks for this library of scripted cyber attacks. There's over 1,300, I call them atomics. Each individual scripted cyber attack I call an atomic. So there's over 1,300 atomics that span Linux, Mac, Windows, cloud, and containers. So that's exciting that it's cross-platform. And Red Canary also provides a dedicated Slack workspace where anybody interested in attack emulation can join and ask questions and even get support on using the Atomic Red Team project and how to get started. MITRE ATT&CK, as you know, defines very well the tactics and techniques being seen by attackers in the industry today. And sometimes the website or MITRE ATT&CK gives some examples of how an attacker will do this, but Atomic Red Team really comes in and fully fills in that space of what are the procedures. So if we read about in MITRE ATT&CK a technique of, say, brute forcing passwords, and maybe we're a defender or maybe we're a pen tester and we want to actually do that, maybe to find out if we can block and defend against these attacks. Well, if we go to Atomic Red Team, we'll find more than 10 different ways to do brute forcing attacks. The actual commands you type, so you can actually try it and know for sure in your environment how it will handle it. Here I have the MITRE ATT&CK Navigator, which is an interactive tool for looking at the MITRE ATT&CK framework. So across the top, you've got the tactics the MITRE defines, and then each of the cells below is a technique. So what you see on here is a heat map of Atomic Red Team on top of that framework. So the light shades of pink mean that there's at least one atomic test written for it. And as the shades of pink or red get darker all the way up through dark red, that means that technique has 10 or more atomic tests written for it. So here we see under credential access, let me get my pointer working. So here we see under credential access, we have brute force and it's turned red, which means that Atomic Red Team has more than 10 scripted cyber attacks for that technique. So at a glance, we can really tell that Atomic Red Team has pretty good coverage of this whole MITRE ATT&CK space just by looking at it on the Attack Navigator here. So why might we want to emulate attacks? So the way I started out with Atomic Red Team is I just wanted to learn. I wanted to understand different ways of doing stuff. Maybe I, as a pen tester, I wanted different ways to have persistence. So I can go into Atomic Red Team, look up the persistence tactic in Atomic Red Team, which shares the same numbering system with that MITRE ATT&CK has. And I can look up, well, you can do it this way and this way and this way and this way, and not only mention it as a list like that, but yeah, so it gives us the commands to actually run. So sometimes I get frustrated. I'm a super hands-on person. So I get frustrated if I read maybe a blog post that is just high level. So you don't get those actual commands. And I'm like, but I want to try it. And so that's really what I love about Atomic Red Team. So we can also use the Atomic Red Team library, those atomics, those little scripted cyber attacks, to develop our detections. So maybe we already have a detection, maybe we don't, but we don't know. So we could emulate the attack, we could run the atomic test, and we could say, was it blocked, was it detected? If it wasn't blocked or detected, then we could work to create a detection. And after we create the detection, of course, we want to emulate it again and say, okay, does my new detection actually work? We really want to find out that what we're doing is actually working. And then we can use it long term to validate people, processes, and technology. So there's a lot of things in our defensive system that need to be in place and working in order for us to defend. So we have to have people who know what they're doing, and when they see an alert, they know how to handle it and decide if it's a true or false positive. We have different technologies, and we have tools that are configured to collect telemetry, and that telemetry needs to flow across the network, maybe to a central location. And then we have to have alerts written to look at that information, and those alerts have to actually go off and be seen by people. So beyond just developing detections, we can use the scripted cyber attacks for continuous validation, and also to tune our configurations to keep telemetry for the most important events. And how do we decide what's most important? Well, for security, we emulate those attacks and say, what pieces of this telemetry or logging do we need to keep track of in order to know that this bad thing happened? And so we can use Atomic Red Team to find out what those most important events are. And also to be cool, the last item here is to be cool like me. I'm a grandma now, and who wouldn't want to have a hacker grandma to be able to say their grandma's a hacker? So you could be cool by doing attack emulation. Okay, so Atomic Red Team is a project found in GitHub. GitHub's a great place for code type projects where multiple people can work on something without stomping on each other's changes. So you find Atomic Red Team in the GitHub repository, and you're looking at the files. If you went to the main GitHub page here, you're looking at the files. There's a lot of stuff here, but pretty much all of it is just supporting information except for this atomics folder. So don't be scared when you go there and you see all this stuff. It's really just auxiliary stuff, and the real nitty gritty of it all is in this atomics folder. That's where the entire library sits. And so we click on this atomics folder, and that takes us into a folder that, with the exception of this first folder, is all MITRE technique numbers and sub-technique numbers. So here we have technique T1003, sub-technique number 1, sub-technique number 2, and this goes on and on and on. So all those red, pink items that you saw on the MITRE attack matrix, each one of those folders has a folder here. And so if you wanted to know what scripted cyber attacks are there for sub-technique number 1 of technique T1003, you would just go right into there. So let's click on one of these T1003 folders, or actually one of these T number folders. In this case, for this slide, I clicked on T1218 number 11. We're going to be playing with that technique or that atomic test today. So in here, we're inside of the T121811 folder. Inside of each of the T number folders or technique number folders in Atomic Red Team, you'll find at least 2 things. One is the markdown file .md that I have outlined here, and the YAML file. So the YAML file is the machine readable version of all the atomic tests, laid out in a very prescripted way, but it's really not fun for humans to read it in that format. So this project provides a nicer human-friendly readable version, the markdown version. So we're going to look at the markdown version today. So we click on that file, and here's an example of atomic test number 2. So it's one of many tests within this markdown file within Atomic Red Team for emulating technique T1218 sub-technique number 11. So this is running DLL32 to execute a VB script command. So we've got a description. Let me get my pointer here again. We got a description. We see it's for the Windows platform as opposed to Linux, Mac OS, or cloud. And we see some input arguments here that make it configurable. And lastly, this one-liner command. So we can actually emulate this attack technique with a single command here. And we're going to look at that a little deeper in the next slides. Here, I backed up a little. At the top, we have the MITRE ATT&CK website talking about technique T121811, subtechnique 11, which is system binary proxy execution using run DLL32. And then I've got the markdown file outlined in blue on top of that we talked about. So let's take a closer look at that markdown file. So here is that markdown file again. We have this section here with the text or with the boxes. We have some input arguments, in this case, only one input argument. So we have the command to execute is a variable, and by default, that's set to calc.exe, so just calculator. So what this command is going to do is it's going to proxy the execution of the calculator built into Windows through run DLL32, or in other words, run DLL32 is going to run calc. So maybe if there were application whitelisting in place, and you couldn't run random executables that an attacker might want to run, they could use run DLL32 to run that for them, since that's likely to be allowed through the policy. So that's one example of the use of this. So here you see run DLL32. This is an example really from some malware that actually uses it like this. So they use run DLL32 in this really awkward way to run an HTML application and ultimately run a VB script. So you may wonder, well, if the malware tried to do that in my environment, what would happen? Well, it's really hard to say unless you actually try it, and Atomic Red Team makes that possible. Here we have at the end, you see this hashtag squiggly command to execute. That's means it's a variable meant to be replaced by one of these input arguments. So in this case, it's going to put in calc. But as we execute this, instead of running calc, we could maybe run something that's more realistic of a real attack than just running Microsoft's calculator, for example. But that's all configurable as we run Atomic Red Team. And there's additional features of Atomic Red Team besides just the attack commands that we looked at. There's also prerequisites. So some tests require some tools or settings that aren't on Windows by default. So a good example is this test here that uses the sdelete tool for Microsoft sysinternals. That doesn't come on Windows by default, but it securely deletes a file or overwrites it with the zeros and ones so that it can't be forensically recovered, something attackers would like to do to keep their what they were up to a secret. So in this case, this atomic test has some dependencies we see here that says the secure delete tool must exist, and it doesn't by default on Windows. And then it has some automated commands to check. So it's just going to check if the sdelete tool is on your system. And then if it isn't, we can use these commands down below for getting the prerequisites. So this is just makes testing much easier. So when we're on our test systems, we're not constantly having to go download and install a bunch of things manually. We can just say, hey, I want to run these 5 tests. Go off, please get the prerequisites for me, and it will take care of that in an automated way. So as these tests get a little more complicated, so we have configurable arguments, we have potentially some prerequisites or multiple prerequisites that need to be checked and downloaded. We have even cleanup commands that will delete files that each test creates, or reset a registry key, or restart a service so that we can run the test again. It gets a little harder to just copy and paste a single command because we've got those variables we need to replace. So that's why we have some execution frameworks available to us. So Atomic Red Team itself is literally just a library. It's like books on a shelf. It doesn't do anything in and of itself. It's just like you can look things up like, oh, I should run this command to run this attack. But if we actually want to do it, especially in an automated way, we should use an execution framework that knows how to follow those directions. So it'll read the library and say, oh, I'm supposed to run this from an elevated command prompt. I'm supposed to do it in command, not prompt, not PowerShell. I'm supposed to run these commands after I input these arguments. And then this is what I do to clean up and get prereqs. There's a lot of different execution frameworks you can use. Red Canary provides one called Invoke Atomic Red Team, which we're going to talk about today, but there's others like MITRE, Caldera that do the same thing, Prelude Operator, and some commercial ones as well. So, and a Python one. So don't get too hung up on the execution frameworks itself, because that could really be anything. The real value of today is talking about the actual library of those 1,300 plus scripted cyber attacks. So Invoke Atomic Red Team is in the same organization on GitHub, so Red Canary Co. If you go there in GitHub, you'll see Atomic Red Team. And you'll also on the right, you see Invoke Atomic Red Team. So Invoke Atomic Red Team is the execution framework. It's a different project. So you need to go into that other repository to see that. It has a great, if you click on the wiki, it has a great page here where it talks about how to install it, how to import the PowerShell module to use it, how to list atomic tests, how to get and check your prereqs, how to run tests locally or against a remote machine, specify custom variables, do your cleanup, and even how the logging works. So there's a lot of great resources there. And there's even links within this wiki to also that Slack workspace. We'll just look at the footer in the wiki. There's also a wiki for the Atomic Red Team project, in addition to the Invoke Atomic Red Team that has that as well. Okay, so now we're going to go back and look at the same test, atomic test number 2, executing VB script through run DLL32 to launch the calculator. So here's how it looks using the execution framework. So I have the execution framework installed, and so which gives us this command, invoke atomic test. And then we just specify the technique number that we want to run. And in this case, I'm adding an extra flag here that says show details brief. And what that does is just list out the names and numbers of the tests that are available under that technique number, subtechnique number 11. So I say show details brief, and then it prints out tests 1 through 13. And if we compare that with what we saw on the website, so if we're on the website looking at Atomic Red Team, we'll see also in that markdown file a list of tests. So these match up, with the exception being that when we're running Invoke Atomic Test, since we're running Invoke Atomic Test on Windows, it's only going to show us tests that apply to Windows. It looks like maybe all these tests apply to Windows. Well, yeah, because it's run DLL32, so that makes sense. But if some of these tests were meant for Mac OS or Linux and not Windows, they wouldn't show up in this list since we're running the execution framework on Windows. So it's a little bit smart in that way. This execution framework, it is written in PowerShell, but with PowerShell core installed on Linux and Mac, it also works cross-platform. So this is a cross-platform option for you. Okay, so this time I've taken off the show details brief, and I'm just listing out show details. So right here, we've taken off the brief, which means, oh, and I've also added in -2. So I've specified, hey, execution framework, I'm interested in the details only of test number 2. Please show me the details. And then it lists out essentially the same information that you see on the markdown file, just in the command prompt here. So it's laid out a little different, but you see, we still have a test name. We have a GUID, which is a scriptable way to refer to this test that doesn't tend to change like other test numbers and names do. It says run with command prompt. And one thing you get when you use the execution framework is this last line, command with inputs. You can get a copy of the command with the variables filled in. So here you see where this red text is, one of these variables, hashtag squiggly command to execute, gets filled in with calc. That makes it easier. If you did want to copy and paste this yourself and run it in command prompt, that makes it so you don't have to copy and paste that variable in. So I do like that about this execution framework. So now we've decided, yes, this is the test we want to run. I take off any of the extra flags like show details or show details brief, and I'm just telling the execution framework I want to run atomic test number 2 from this technique and subtechnique number. And there we see it having run. It pops calculator, it leaves this HTML application page over here, and that's how it worked. Now we could go and say, well, first of all, did it work? Well, yeah, it did. It popped calculator, but how did that look amongst our telemetry? Is there a way for us to pull this out from normal activity in our environment to decide that this was done? And let's see, I've got maybe 15 more minutes. So as part of this, every time you run a test, by default, the execution details get logged to CSV file. So, and it looks like what you see on the screen there. So you've got execution times, you got technique numbers and GUID numbers of the test, and then the host that it was run on. So in this case, the local host, and the user that ran the test. There's also, and that's all you get with the default log, but there's also the team at Vector. They added to the Atomic Red Team project a really powerful logging mechanism, which you can optionally use just with an extra parameter on the command. This is to log in JSON format, and that JSON format includes all of the input to the test and all of the output. So you could actually go back and look after the fact, did it really pop calc? What was the response in the command prompt when it ran? And so that's really powerful, and also makes it importable into the Vector Purple Team reporting tool, which is free and a great way to track campaigns from a offensive and defensive or blue teaming, purple teaming type scenario. So let's talk a little bit about how we might use Atomic Red Team in our environment. So one way we might use that, I've got a computer here and it shows that we've got Atomic Red Team installed on it, the blue arrow indicating that we're running atomic tests against this same machine where we installed Atomic Red Team as opposed to against a remote machine. I've got this little AV symbol to show that you may or may not want to have AV on. When I started at SANS, I heard this quote, I don't know who to attribute it to, but prevention is ideal, but detection is a must. So I actually recommend that you at least try all the atomic tests with AV turned off, because you know, there's, as a red teamer, there's really endless ways to get around the defenses and allow something to run. I do an atomic spotlight every week where I show how to run some atomics, and we're bypassing AV in there often just with small tweaks. So it's really important that we find out how good our detections are. Will we know that something bad happens even if our blocking mechanisms get bypassed? And then the G just represents a golden image. So create a system that's representative of something you would give to an employee, the things that, the kind of systems and configurations that you're trying to protect. So we could set up like that. The great thing about that is it's quick to do. You just take a existing representative laptop, you install Atomic Red Team, and you run the test. And we also should ship that telemetry that we get from doing that to, if possible, our production central collection agency, so that we can use our production detections on this data as if it had happened in production, even though it didn't, or you may not want it to, so you keep it in a test environment, but we can still exercise our production detections in that case. The bad thing about this is that installing Atomic Red Team is what I would say is heavy, because you have to install a supporting PowerShell module to read YAML, and it downloads a bunch of simulated malware into a folder. And if you don't do anything beforehand to prepare for this, you're going to set off a bunch of alerts locally and on the network for bringing down all the stuff that looks bad, because it really does look similar to malware, but it's intended not to do the actual harm that malware does. So that's the drawbacks to this. Another version of is that you could execute atomic tests against a remote system, so you don't have to install Atomic Red Team there. So the advantages of this is it's a much lighter footprint. So you can have any system of any OS where you install Atomic Red Team, and then you run that against your kind of representative image, and you you don't set off all those alarms. The only thing that ends up on that remote system that you're testing is that this, let's say you're only running one atomic test, is that one atomic test that you're trying to run. So you're not going to get alerts for all these other things. And you can actually spot check real systems. So maybe this isn't a test system. Maybe this is really Bob's system over in county, and you want to say, hey, if somebody uses CertUtil to download something which is not a real common use of CertUtil on a real system, would we really see it, and would our analysts really react to it correctly? So those can be really good tests. And just as a cautionary statement, like I mentioned, this will set off a lot of alerts, has a lot of simulated malware in it, and you know, it even will download Mimikatz if you run that test, which you may not have permission to be putting on your network. So you want to be careful. Start in a test environment, make sure you understand the tests and what they do, and before you move them anywhere else where they could do damage. And if you want to learn more, Atomic Red Team and GitHub and Invoke Atomic Red Team both have excellent wikis. So lots and lots of details, even about how to contribute to Atomic Red Team. So if you have an idea for an attack emulation, you read a blog post and you find that hasn't been emulated with Atomic Red Team, you can contribute that and also get a free t-shirt from Red Canary, which is great. Actually, I have my free t-shirt on here, my Atomic Red Team t-shirt. Let's see, I've done 9 atomic spotlights on the anti-siphoning training YouTube page, where I take 1 or 2 atomic tests and we talk about how they work, what technique they are, why attackers use them, and then we actually emulate the attacks. And so that's also a good resource for learning more. And that's what I have for the presentation. I'm open for questions now.